My dear friends, let's solve another mixing problem. A tank contains 5,000 liters of water and 100 kilogram of dissolved salt. Let's write this information here. Our initial volume, which is V sub 0, is 5,000 liters. And our initial condition is that it has 100 kilogram of dissolved salt. So, fresh water is entering the tank and at 20 liters per minute. And let's write this flow in information here. And also below it, I'm gonna write the flow out information. And since this is a fresh water has a concentration of 0. So C1 is equal to 0 and its flow rate is, input flow rate is 20 liters per minute, which is R1, 20 liters per minute. And this solution drains, which means it goes out, its outflow is with rate 15 liters per minute. So remember, C2 is a function of T and R2 is given us as 15 liters per minute. And from this information, I can directly write the volume formula, which is here in the denominator of C2T. And the volume formula was, let me make you remembered, V0 plus R1 minus R2 times T. And here R1 minus R2 at each minute, observe that our volume is increasing at a rate of 5 liters per minute. And after T minutes, of course, our volume will be what? Our initial volume was 5,000 liters and plus 5T. All right. And we are going to assume that the solution in tank remains perfectly mixed. I have explained this assumption in my previous video. What is the function that models the amount of salt YT at any given minute T? We are going to build up and solve our differential equation. This is our differential equation, remember. Let me plug the values in our formula. dy over dt is equal to, since C1 is equal to 0, I don't need to write this first term zeros away. And what about the second one? Minus y divided by this Vt function, which is 5,000 plus 5t and times R2. And R2 is 15. So let's take this into a 5 parentheses, which gives 1,000 plus t value into the parentheses, and this went away. And I'm going to cancel this 5 and 15, remaining 3 here. And so the numerator makes, observe that, minus 3y divided by 1,000 plus t. And this is the left-hand side, this is the right-hand side. So this is a separable equation, right? And in order to separate these variables, I'm going to change this dt and y terms to obtain dy over y is equal to minus 3 dt divided by 1,000 plus t. And now I can integrate both sides. And what is wrong with this integral? Okay, this is better. And this left-hand side integral of 1 over y is ln y. Remember. And integral of 1 over 1,000 plus t is also ln 1,000 plus t. Why? Because the derivative of ln 1,000 plus t is 1. So we have minus 3 ln of 1,000 plus t and an integration constant. Instead of c, I'm going to write ln c because all the other terms are ln. And next, I'm gonna make these regulations. This minus 3 goes as exponent right here by the property of ln function. and this went out. And I have the two ln's of two terms, which yields the multiplication of these terms inside ln. So this lnc also goes away, leaving a c here. And finally, I obtain both sides ln of something. And also at the end of the day, these ln terms also go away. What we are left with is the function y of t. Let's write this term to the denominator. And it is c divided by 1000 plus t cubed. And let's apply our initial condition. y0 is equal to 100. And so y0 is equal to 100. And this is equal to, when we plug 0 in t, we obtain 1000 cubed. And 1000 is 10 cubed. 10 cube makes 3 times 3, 9. So it is c times 10 to the 9. But 100 is also 10 squared. By cross multiplication, what we obtain here is c is equal to 10 to the 11. So when we plug 10 to the 11 in c, what we obtain is the yt, complete yt function. It is 10 to the 11 divided by 1000 plus t cubed. My dear friends, I am done with the function part A. And let me write part B. It is just an evaluation of the function at 15 because we are asked how much salt remains in the tank after 15 minutes. And this is also the function that gives us the remaining salt after t minutes. And I'm going to evaluate this function at the value t is equal to 15. So y15 is equal to 10 to the 11 divided by 1000 plus 15 cubed. And the result is, of course, for you, my dear friends, I have calculated it before and found 95.63 liters. And let's spend a few words that interprets this result also. We have initially 100 kilogram salt, right? And here we have 100 kilogram of salt. But the input rate, input concentration is 0. I mean, fresh water is entering to the tank, not which means that the inflow process does not contribute to an increase of y of t, and the initial amount of 100 kilogram of salt slowly removes from the tank, and after 15 minutes it makes sense that it decreases to 95.63 liters. And that's all for this problem. Take care of yourselves until my next video, and thank you very much for listening to me. Have a good day.